Arriba! Let's talk about voltmeters and ammeters, which turns out are not ideal. Then a tricky subject known as a potential divider for splitting voltages. And then we'll talk about some little clever sensors that can be used in potential divider circuits. You could follow along in your ISM packet on pages 13 to 17. Let's talk about ammeters and voltmeters. Let's start with a drawing, and we're going to call it figure 5.9. So let's say that you have a battery here, and you got to put your ammeter in series with it, and let's say you got a light bulb, and that's your circuit. If you want to measure the voltage of your light bulb, this has to be in parallel with your light bulb, and that's how it works. If you have an ideal ammeter and voltmeter, you will assume that your ammeter has no resistance, and you will assume that your voltmeter has a resistance equal to infinity. And that, if this is infinity, that makes all of the current flow through your bulb. If this has no resistance, that means it doesn't steal any of the voltage. However, it's not really like that. If we make another drawing called figure 5.10, we can draw basically the same thing, but in reality, your ammeter has a small amount of resistance in it, and that will cause your ammeter to steal just a little bit of voltage. Then that's going to go to your light bulb, and your voltmeter does also have a small amount of resistance to it, and you can think of your voltmeter as being in parallel to this small amount of resistance. This is within your voltmeter. So what you can think is that your ammeter, in reality, has a tiny resistance that steals some voltage. Your voltmeter has a very large resistance, but not infinite. So it will still use up some current as the electricity goes through it to make that needle move. Hopefully you've realized that most any circuit that has stuff set up in a series is a potential divider. Let's say we've got a 12-volt battery, like a car battery, and it's got two light bulbs on it, each of the same resistance. Hopefully, by working some series circuit problems, you know that this is going to receive 6 volts, and this receives 6 volts. And if you had a whole bunch of those, like if you were having a Merry Christmas or a Feliz Navidad, if you will, then they're going to split all of these equally. And if there's 6 bulbs equally splitting 12 volts, 2 volts, 2 volts, 2, 2, 2, 2, everyone gets 2 volts. It's like a 2-volt party. And then if you had one bulb that had twice as much resistance as the other one, this guy would be like, give me more of the volts, and he would get 2/3. So he would get 8 volts, and this little weak guy who's like, oh, I don't get as much, he only gets 4 volts, and they're splitting up the voltage unequally. So let's say you want to set up a dimmer switch. You can do that, or one way, is by putting this thing, which is going to be our variable resistor. Some people might call it a rheostat. I don't know if that's how you spell resistor, but anyway, that you can adjust how much resistance it has, and if you put that in series, so we've got a 20 ohm bulb, if you've got 9 volts here, they're going to split up this voltage. If this is cranked up, and let's say its maximum resistance is 40, then it's going to receive 2/3 of the volts. And this light bulb will only get 3 volts, and maybe it's quite dim, you're having a nice romantic dinner. But then you can, if you want it brighter, take this all the way down to 0 resistance, and that's going to give it 0 volts. And this is now going to get all 9 volts, and it's going to be super bright. Now, a problem that you might have with this is if you've maxed out your variable resistor and it only goes up to 40, then your bulb is only going to be it's still going to be receiving 3 volts, and maybe it's always glowing dimly, and you'd like to be able to give it anywhere from 0 all the way up to 9. You can make a clever, what I call a clever dimmer switch, if you take your bulb or device that you want to dim, and if you put it in parallel to your variable resistor as opposed to in series. So let's say we've got a switch here, and we've got our 40 ohm variable resistor here, and our light bulb is placed with a wire on a slider that can connect anywhere along this variable resistor. If you then connect the switch, the power goes on, and if you can connect, let's say right in the middle, there's going to be 20 ohms of resistance here and 20 ohms of resistance here. And that's going to cause, let's say, here's 20 and here's 20. They're in parallel. Maybe there, you combine those, you're going to get 10 ohms of resistance here. And you have another 20 ohms of resistance here. Well, what's going to happen is this 20 ohm resistor might get 2/3, so it might get 6 volts. In parallel, these might combine to only give you 10 ohms, and so each of these might be using up and getting 3 volts, each one. They're in parallel with each other. And then you might say, well, can I make the bulb all the way bright? You can't, because if you make the slider come over here on the edge of the variable resistor, this whole thing is getting all 9 volts. The bulb's now in parallel with it, so it gets all 9 volts. So it is super bright. And then you might think, well, can I give it 0? Yes, you can. Because if you slide it all the way over here, it's in parallel to just a wire that has no resistance. And if there's no voltage difference here, then there'll be no voltage here. And the variable resistor receives all 9 volts. This is just like when a bird stands on a telephone wire, it doesn't get fried because there's no resistance between its legs. And so no electricity is going to flow if there's no voltage difference. Now you can make different sensors act as voltage dividers. And a common one that gets brought up a lot is the LDR, or a light-dependent resistor. What this guy does is that its resistance will go down as the light intensity goes up. And it might go anywhere as high as, let's say anywhere from 1,000,000 ohms when it's really bright out to maybe only 100 ohms when it's dark. So in bright, let's say you put it in series with a lamp, maybe a street lamp that you want to turn off when it's day, and turn on when it's night. So when it's sunlight and bright, that's all coming down. This is going to jump up to like 1 mega ohm, and it's going to be greedy and steal all 220 volts because this only has 15 ohms. So it gets essentially 0 volts, maybe a little bit more, but not much. When it is dark out, this voltage or resistance plummets to maybe only 100 ohms, and this still has 15 ohms, but now we're splitting 220 volts. This will still get some that will allow it to light up. And it may not be fully bright, but maybe that bulb can't handle all 220 volts. And there's other sensors like thermistors that their resistance changes based on temperature, but this is just one example.